Okay guys, so we've got to a very healthy place now with optics. We've gone through Young's double slit experiment for interference. We've looked at diffraction. One thing that I did want to talk about a little bit about is this idea that comes up in the Caboodle book, and the idea of what they call a phaser. Now each of these points in a single slit, let's pretend we've got quite a wide single slit over here. And we know that based on Higgins's principle, each of these are going to operate as a source of oscillation. Okay, now the ideas that are presented in, I'm not going to go into too much detail about them here, aren't massively required for your specification at the moment. Okay, so don't worry too much about these. But what I did want to say to you very quickly is there's a few bits and pieces that we want to talk about. One of them is spectrometer. Okay, now you would have heard about various kinds of things. You would have heard things like line spectra. Now these are quite heavily used in the analysis of light from stars and from outer space, because they give us a bit of an indication of the potential position in which things exist and the distance they exist from. So those of you that did separate sciences, you would have looked at an idea called red shift. And the idea that if you imagine light arriving at the Earth's surface, because of potentially being diffracted by entering a more dense medium, we're going to get the spectrum appearing red all the way through the range of colours. And I always remembered it as Roy G. Biv. Okay. Now what you want to remember is that as these rays of light are incident onto the Earth, some of them will get absorbed. And it's not so much the colours that we're interested in, it's more where these black lines appear. Okay, the one way you could potentially look at this is you could regard it almost like the fingerprint from a star based on the black lines and where they come from. Now, if the rays of light from that same planet, we're still going to get the same colours, but where the black lines appears to have moved, you can see, looking at this diagram here, what you've got is that they've moved towards the blue end. That suggests that objects are getting closer. If, however, the black lines have moved in the opposite direction, we will just show that very quickly over here. Excuse the scale I've used here. Now you can see they've moved towards the red end. We call that red shift, and it gives you a bit of a suggestion of the position of an object, particularly something that either emits its own light or potentially is reflecting light off something. Now that can happen for a number of reasons, because quite often what people have always thought, especially when you speak to very, very young children, is that you have the sun here in the middle, and you know, it's obviously the happiest, hottest part of the solar system, and everything essentially moves in a circular fashion around it. We call a concentric model. But in actual fact, as we know, there are planets that have almost like a looping kind of orbit. So at some points they'll be closer, and at other points they'll be much further away. And that's where this becomes quite an important piece of information. So that's a simple use for line spectra. Now what I want you guys to do is have a look at your own uses, and you want to be looking at the use of a spectrometer and also for diffraction grating. Okay, feel free to have a look at phaser diagrams. I'll be doing a a video for this a little bit later on, but just want you to know that at the moment it isn't what our main concern is. For this topic, the big thing that you must be aware of is unit conversions and really reading the question very carefully to make sure you've understood what the question's asking you to do. Alright guys, as ever, email me if you have any issues.